Okay, so like I was saying yesterday, we were working on transformations of quadratics. So as you guys remember, we have our A, our H, and our K. Do you guys remember which one I said has to do with the vertex? Which letters out of A, H, and K have to do with my vertex? Jade. H and what? There's one more. Say. Okay, H and K. So like I always said here, H is always opposite of what it seems. This is 1.5. Yep. So if I have something like f of x is equal to x plus 4 squared minus 3, my vertex is going to be -4 and -3 because h is always opposite of what it appears. So if I give you guys a different one, let's say x minus 3 squared plus 2, can someone tell me what my vertex is going to be for that one? Olivia. 3, 2. So the key thing to remember here is that A and K, they're always going to stay the same. Okay, so they're never going to switch their sign, unlike the H. Okay, so A and K will always remain whatever they appear to be. H is the only one that switches because we have to basically solve for x in the bracket. Yes, Emma?
Sorry, so the vertex would be 4 squared. How is it different? I thought it would be, sorry, no, yeah.
For which one?
For the one, the top one.
This one?
Yeah, I thought it would be -3.
Yeah, it's here, -3.
Oh, okay.
Yep. -3 stays the same, and +2 stays +2. The only
H
would just be opposite of what it seems. So as you see how you have an x plus 4?
Yeah.
Some of you would write +4.
But it would be negative.
It'd be -4.
Oh.
So like I said, what does A help us do? So A is responsible for telling us the direction of our opening. So like we said yesterday, if A is negative, our graph opens which way? Down. So if A is negative, so when A is less than 0, the graph opens down. And by less than 0, I mean like the negative number. So like -2, -1, -2, -3, etc. When A is bigger than 0, which means when A is positive, so we're going to take all the positive integers like 1, 2, 3, etc. My parabola is going to open up. So this guy over here, y equals 3x squared, is going to open up. And y is equal to -4x squared. It is going to open downwards. So let's see if you guys remember. When my graph is opening up, do I have a maximum point or a minimum point? Yep, minimum. And when it opens down, what point do I have? Yeah. So I have a maximum point at the vertex. And also what we discussed yesterday was the idea of stretches and compressions. So we said if A is a number that's bigger than 1, that means we have a vertical stretch, which means my graph is getting skinnier. But if A is a fraction, that means my graph is going to be basically fat and wide. Yep. So if A is a number that is bigger than 1, so for example, if we have -2, 2, -3, +3, -4, or 4, this just tells you that my graph is going to be skinny and it's going to be stretched out.
So that's for A?
Yep.
So anything that's negative, it will be...
No, negative or positive, doesn't matter. As long as it's bigger than 1.
Okay, so it could also be like 1, 2.
Well, not one. One is just the basic graph,
Okay.
so it has to be bigger than one. Can't be one.
Okay.
That's why I have negative 2 and 2, negative 3, 3, negative 4, 4.
And then it would go wider and
If we have a fraction.
if you have that.
Yeah, so a fraction that would make it a compression would be something like negative 1 over 3, 1 over 2, 1 over 8, 1 over 6. Remember, they all have to give me something that's less than 1. So 1 over 8 is like 0. I don't even know, 0.222, I think. 1 over 2 is a half. Negative 1 over 3 is negative 0.333. Those are all values or fractions that give you a value less than 1, or less than 1, but bigger than 0. So this means that my graph is going to be fat, basically, wide and fat.
So whenever it's a whole number.
Fraction.
Oh, sorry. Yeah, but the other one, whenever it's a whole number.
Yep,
Right?
a whole number bigger than 1. Yes, Rebecca? Yes, Benjamin, what question do you have to stump me with?
What's the your mom factor?
Oh, so one of the girls in my first period class, she just said, you know, when you say something and then your only comeback is your mom, that's
Oh,
where
like
that,
when you said the graph is going to be fat and wide, and then I would say like, oh.
yeah, your mom, yeah, basically. That's what she says. So we count every day. The worst one was 10. Said 10 times in class.
Oh my God, I see your name.
Jay, do you understand a counter for you?
Yes. Literally, look at my.
Rebecca, tell me, is this fine? Yep.
Jay, have we ever switched vertical compression and vertical compression? Never do a horizontal compression?
So the thing is, there is such thing as a horizontal stretch and horizontal compression, but we just don't get into that with the M course.
Oh, okay.
But it would work the exact same. So let's continue on. So again, like we were discussing with our h, is if h is bigger than 0, the parabola has a horizontal shift of h units to the right. So what that means is when I write it in my bracket, I have to have this minus 2 in there, because when I set my bracket equal to 0, I get x minus 2 is equal to 0. And when I move my negative 2 over, what happens to that negative 2? It becomes positive. So because my value becomes positive, this means I move 2 units right. And then the same thing is applied to when we move to the left. I just want to read this. Hold on.
Yeah.
So when h is less than 0, so when it's a negative number, the parabola has a horizontal translation of h units to the left. So again, that happens when my bracket has a positive. Remember, like I said, h is always opposite of what it appears. So if you think it's positive, it's actually moving to the left.
So that means that since the one of -2 is actually
Yep.
positive, it is
Yep.
positive.
Yep.
And then it moves to
Units.
yeah.
Yep.
To the right.
Yep. And the reason being, like I'm going to show you here, is because I need to set my bracket equal to 0. So I get x plus 3 is equal to 0. And once I move that positive 3 over, I get my solution to be x is equal to -3. And we always associate negative numbers with the left side of my x-axis, and these are all negative. And when we get a positive number, that associates with my right side of the x-axis, which is all of my positive values. So positive means move to the right, negative means move to the left. Yeah.
Can you explain the first part of the x take away 2 that you did there?
Oh, so whenever we have something inside of a bracket, it's known as a solution to the equation, meaning that it is an important point, okay? And when I set that point equal to 0, that will ultimately help me find my, in this case, my vertex and where my axis of symmetry is. So in order for that to happen, I have to set that whole bracket equal to 0. So I get x minus 2 equal to 0. I move the -2 over. And when I move a negative over, it becomes positive, and I get x is equal to +2. And when we talk about the positives on the x-axis, are we talking about the right side of the x-axis or the left side? So when we talk about positive numbers, is that on the right side of the x-axis or the left side of the x-axis? Right side. So we associate positive numbers with moving to the right.
Wait, so why do positive numbers go to the right?
Because we always have our, pardon?
Is that because of how it is on the graph?
It's just how it is in like the axis, your x and y axis. Positive numbers are always on the right or going up and down. But in this case, the x's are positive on the right side, and my negative numbers are on the left side of the x-axis.
Well, Cynthia said she never heard.
That's rude. Hi, Cynthia.
Probably dancing.
She didn't respond. That's rude. I'm offended.
She's a sweet No, she's not even type.
Okay to move, or do you guys need a couple more seconds? Yeah.
Why do you have to do like all that math? And isn't it just kind of common sense? The opposites of
Yeah, but some people want to see how it's proven algebraically. That's why.
Oh, so you were solving it when you were talking about all that.
Yeah.
but-
You can literally just go with what I said, and it's opposite of what it seems, and you don't have to really do all that math.
Yeah, that makes
I was just showing you the math way. No, if you say it moves 2 units to the right without showing work, that's fine. I don't care. And now the last part, which is the easy part, which is k. So when k is bigger than 0, so when k is a positive number, it just means moving up because my k values, or my k, has to do with the y values of the graph. So if my k is a positive number, which means bigger than 0, that means I'm moving up a certain amount of units. So for example, the first one, y is equal to x squared plus 4. Because my k is plus 4, that means I move 4 units up. Now, when we do the opposite, when k is negative, so when I have here y is equal to x squared minus 5, the negative 5 is my k, and this just means I move 5 units down.
I thought that would be. So then what would be your H?
We don't have an h here because there's nothing in the with an x in a
In a
bracket.
So if it's in a bracket, then that would be the H. But whatever you add is that.
Mhm. So now I'm going to give you guys one full equation with all 3 of them, and I want to see if you guys can tell me what the transformations are and what my vertex is. So I'm just going to write the equation over here. And write, like A, vertical stretch or compression, which is your A, your horizontal shift, which is your H, how many units you move left or right, and K is your movement up and down. Okay, so let's label them A, H, and K first before we do anything. What's my A and what's my H? What's my K? Rita.
Our A is 1 and 2. Our H is the
Mhm.
and then K is
Okay. So now when we write these transformations, we start with our A. So if you guys remember, if my A is bigger than 1 and it's a whole number bigger than 1, it's a stretch. But if it's a fraction that is not bigger than 1, then it's a compression. So would we have a vertical stretch or compression in this expression or in this equation over here? Okay.
vertical compression.
Vertical compression of what? What's the number there? Yep. Vertical compression by 1/2. Now, can someone tell me if I'm moving left or right and by how many units?
I don't know. Wouldn't it be a stretch because oh, never mind. I wrote it wrong.
Oh, you wrote the opposite?
Yeah, I wrote the opposite.
Okay. Rita.
It would be, that was a fly. No. It would move 2 units to the right.
Yep. Horizontal shift of 2 units right. And who can tell me my last transformation with the K? Paulina? Yep. Yep. Vertical shift of 3 units up. And last but not least, if I were to ask you guys what my vertex is, what would you guys tell me? Thank you, Ashton. 2 and 3. Pretty simple. Yes, Jade?
So for her horizontal shift,
Mhm.
because it was negative
Mhm.
2, it's the opposite.
Yep. Oh man, we have all these charts to do. Ugh, disgusting. Gross.
I explain the horizontal.
Sure.
Quick and simple.
I'll give you 30 minutes of volunteer hours.
I definitely don't need them. I'll do this out of the goodness of my heart.
Don't break my pen. My
I won't break it.
marker.
I don't even need it. I'm just using it to look like a teacher. So have any of you guys seen those like hydraulic press videos on YouTube? Where some idiot will take a hydraulic press and they'll like squish something for the benefit of no one? Okay. So you know that if anything has a little bit of squash and stretch to it, when you bend it down, all that stuff will go outwards, right? Same thing applies to graphs. So when you squash a graph just vertically, so it's horizontally compressed, it has to go somewhere, so it gets horizontally stretched. And it's the same thing, basically. So if something gets here, for example, is vertically compressed by 1/2, it, like, let's say this is the graph, right? Just whatever. That's just a regular y equals x kind of thing. If you were to compress that by 1/2, it wouldn't just look like this. It would look something like that. Yeah. Same thing from those hydraulic press, right here. There's no difference. It takes up like 2 seconds of 11 units.
You see? Graph will be wide and fat.
All it does is make things more complicated. So just limiting it to vertical stretches and compressions, no difference.
Thank you, Benjamin. You're good.
I'm gonna do a good teacher.
You will. You'll be the next Mr. Summers.
I'm not teaching math. I'm teaching French.
That's fine. Okay, so we have these annoying charts over here with a lot of the transformations that we have. So we're gonna fill these down. So there's specific things that we have to figure out. We have to figure out if it opens up, down, what the vertex is, what my axis of symmetry is. We want to sketch it, and we want to figure out if there's a maximum or a minimum point. So we're going to do the first 4 together. The last 4 you guys are going to do on your own. I'll do every other one, and then we'll do example 2 and 3 at the end. So we'll do the first one together. So I have f of x equal to 2x squared. I need to figure out my a, my h, and my k. So what is my a value in f of x is equal to 2x squared? What is the a, Jade? 2. Do I have an h? Nope. So h is 0. Do I have my k? Nope. So k is also 0. So based off my a value, remember, think of it as positive and negative. Does it open up or down? Lisa? Up. Remember, my vertex is h and k. So what is my vertex in this graph? 0, 0. And then I have my axis of symmetry, which is known as the x value or the h value in vertex. Yep.
So the x value is the h value?
Yep, it's the same thing. X and h in the vertex are the same thing. So my axis of symmetry will be x is equal to whatever this number is over here. X is equal to 0. So now for the sake of graphing and not going to Desmos, because I have an a value of 2, and what Benjamin just explained, how is this graph going to look? Is it going to be stretched, or is it going to be compressed and be fat and wide? Someone said it. It's going to be stretched. So I'm going to label my key point, which is my vertex. So 0, 0, that is my vertex. And my graph will probably look something like that. If the a value is a whole number that's bigger than 1, then it's stretched. If my a value is a fraction like 1 over 2, 1 over 5, 1 over 4, then it'll be a wide and like wide and fat graph.
So this one's stretched.
Yeah, that one's stretched. Yep.
So because the x and y value is 0.
Mhm. No, it's because of this guy over here. That's why it's stretched. Because there's a 2 in front of my x. Yep. And then do I have a maximum or a minimum? Minimum. So I have a minimum at my vertex, which is 0, 0.
Why is it a minimum?
Because there's a bottom. Does it go below this? No, right? So that's why we have a minimum. So 0, 0 is my minimum.
We're getting better.
Yeah. Okay. This is good music today.
Yeah. Yeah, we're doing sync.
Okay, I'm gonna keep this up here for another 30 seconds before we move on. So we're gonna skip the next one and we're gonna move on to this guy over here. So we have f of x is equal to 2 times x plus 1 plus 4. So what is my a value here? 2. What's my h? Someone said it. Negative 1. Then what's my k? 4. We're on the third one. We're skipping every other one. We're doing every other one. So now we're on number 3. Yep. So which way does this graph open, up or down? Opens up. What's my vertex?
How do we know that it opens up?
Because there's the 2 is positive.
Oh, okay.
Yep. My vertex, like Ashton said, is negative 1 and 4. What's my axis of symmetry? To negative 1. And now I can sketch my graph. So the only important point I need to sketch my graph here is my vertex, which is negative 1 and positive 4. So I'm going to draw my graph. I have negative 1 over here and 4 right here. And then my graph is going to look like this, a skinny graph because it's vertically stretched. So in this case, do I have a maximum or a minimum? Okay, I have a minimum at my vertex. Yep. So as you can see, it's pretty straightforward and easy.
Yeah.
Yeah, we're doing every other one.
You're really flexible.
So the next one is we have f of x equal to -3 times x plus 2 squared to the power of 2. So what's my a value here? Okay, what's my h? And what's my k? 0. So does my graph open up or down? Okay, my vertex is, yep, perfect. And my axis is symmetry. X is equal to -2. See? What the heck? X is equal to -2. So now again, the graph is stretched. I have my key point, which is my vertex. So now I'm able to graph this function out. I'm going to draw my axis. My -2 is going to be over here. So this is my vertex, and it's going to be opening down. And it's going to be a skinny graph because my graph is vertically stretched. Now, with that said, all of the things that we've done so far were minimums. Does this have a minimum or a maximum? Max at -2 and 0. Okay, so I'm going to keep this up here for you guys to copy down. That one is this one, -3 times x plus 2 squared. So should it be the third one, the fifth one?
Do you know if the cafeteria food will ever be like open again?
I have no idea, actually. No clue.
Not that it affects it, because
Hmm.
the pizza was not.
It's okay. And the last one we're going to do is f of x is equal to 3/4, x plus 4 squared plus 2. So what's my a value for this guy over here? 3/4. What's my h? And what is my k? 2. Does my graph open up or down? Okay, what's my vertex? Yep, perfect. My axis of symmetry? Perfect. And now I can draw my graph as it opens up. I'm going to take my axis of symmetry, or my x and y axis. I have -4 and 2 right here. And because I have a fraction as my a value, this one's going to actually be short and wide. It'll look something like that. And do I have a minimum or a maximum for this? Perfect. So I'm going to zoom out a bit so you guys can actually. Yep. That's fine. Okay. So now there are two questions I can ask you. I can either tell you to take my transformations and turn them into an equation, or take my equation and list the transformations. So that would be, I think that's the next page, which says example 2. So we want to change, or we want to write a new equation for our graph f of x equal to x squared with the following transformations. So the graph has been translated 3 units left. So if I were to write this in my bracket, how would my bracket look like? Would it be x plus 3 or x minus 3? You guys, why would it be x plus 3? Yeah, just the opposite. So when I take this out of my bracket, it becomes, so which is why my bracket has to be x plus 3. Now 5 units down means my k is what? So if I were to put this all together, my equation becomes f of x is equal to, there's no a, so we can leave that by itself.
So if
X.
it goes down, it's negative, and if it goes left, it's negative?
So if it goes left, the bracket is positive. Yes?
So we don't have to write.
Nope. No, when there's no a, that means a is automatically 1. Yep. The bracket will always be squared because we're dealing with parabolas. Yep.
So you said no A. And then the second one would be before, if there was no A given to us, we make it.
Yep, it would be 1.
Okay.
A will never be 0.
Okay.
Remember, when you're translating it from words to an equation, when it says 5 units left, your bracket's going to be x plus a number. If it says something units to the right, your bracket is going to have x minus the number. Okay. So now we have example B. So the graph has been reflected in the x-axis and translated 6 units down. When my graph is reflected, which way is it opening? Sarah, down. So reflected in the x-axis means that my graph is going down, which means my is going, oh my gosh, I can't even spell. My graph is going down, which means my a is what? Negative. And is there a specific a value here, or is it just 1? 1. A, so a is going to be -1. Do I have an h? No, so h is 0. Do I have a k? -6. So now I can write f of x. We're not going to write negative 1 x squared. We're just going to write negative x squared
How do you think that's negative 1 for A?
because it's reflected in the x-axis. Whenever something is reflected in the x-axis, that means my graph is going downwards. So my a has to be negative.
So, could you draw that?
So I have my normal graph. Let's say this is x squared, right? It's opening up. And then I have something called y is equal to negative x squared, which is reflected on the x-axis, which means my graph is just going down.
So it's negative 1 because x is equal.
So we have f of x equal to negative x squared. Because we don't have an h, I don't need a bracket. And then minus 6. Okay. For C, we have the graph is vertically stretched by 5 and translated 4 units up. So what would my A, H, and K be? So what's my A in this case for C? 5? Do I have an H? Nope. Do I have a K? 4.
How is that A 5?
Because it's stretched by 5. So my graph is going to become f of x is equal to 5x squared. There's no h, so I don't need a bracket. And then plus 4. D, you guys will do on your own after the lesson is done. And then we're going to do one of the 2 examples from the last problem. And then you'll do the missing examples from the lesson on your own. And you can ask me to see if you did them right after. You'll have around 15 minutes to do them after we're done the last example. Yep.
Why did you just put like 5x squared plus 4? Why did
Because we have a stretch, so I have to include that 5. And then there are times where where you guys are going to be asked to tell me the transformations based off the equation. So, what is my first transformation you see in this one? Y is equal to negative 3x plus 5 squared minus 4. What is the first transformation you see? Sarah.
A is reflected by a factor of 3.
Well, there would be 2. So it's reflected in which axis? Olivia? Yep. So there's a reflection in the x-axis. Now, Sarah, because it's a 3, is it vertically compressed or stretched? Oh, remember, 3 is a whole number, not a fraction. Yeah. Okay. So this is where some of you get confused. When we look at the negative 3, the negative just tells us if it's going up or down. Okay? Then you need to look at my 3. Is my 3 bigger than 1? Yes. Because it's bigger than 1, that means it's stretched. So you would look at the sign first, see if it's if there's a reflection, and then you would look at the number.
Wouldn't it always, would you always rate reflected in the x-axis? The h always gets changed to a negative.
Yeah, so if the A is negative, you always write reflected in x-axis.
How do you know it's reflected?
Because my negative tells me my graph opens which way? Down. So when it opens down, our normal graph opens up. And when it opens down, that means it flips onto the x-axis and goes down onto it. Yeah, we don't touch that in the 11M. Yes, Rita?
So then if A is like just positive, there's no reflection.
Yep, there's no reflection.
What
So
do you
what's-
call that?
If there's nothing. If A is positive, it's just positive, it just opens up. Yep. What's my next transformation? Olivia? Opposite of what it seems. Yep. Translated 5 units left. Remember, it's always opposite of what it seems. And what's my last one? Emma.
It's 4 units.
And translated 4 units down. Okay. So you guys are going to do the missing examples for extra practice.